this homework, and I wanted to give a bit more explanation because some of it is a little bit different and a bit more confusing than the other. So let me be a little bit clearer. We're going to go up to this cartoon here by Esther and what happens when ice melts. Well, this ice then is going to absorb the heat. This indicates that it is therefore a fundamentally endothermic process. All right. So since it's endothermic, here, let me make this a little bit smaller so the writing looks better. Because this is endothermic, you're going to get a plus sign on it. It's going to be positive heat because the energy is absorbed by the system. Now, when the ice absorbs the heat, if it's below 0 degrees, as it is here at minus 8 degrees Celsius, it's going to increase its vibration movement, increase its kinetic energy. And once it gets to 0 degrees Celsius, that kinetic energy will stop moving and all the energy will go towards changing the state. Right? So the change of state is going to be where you get this heat of fusion business. So when the heat of fusion occurs, then the ice starts to melt. Right? So all the energy is going to go to melt the ice, and none of it will go to changing the temperature. All right? So it'll go from here to the little happy water right here. Now, that goes to what you're going to do, which is to deal with this and also deal with the heat of vaporization, which is when it goes from liquid water to gaseous water. But this is the basic formula. All right, instead of one that you dealt with before, it looks a bit like this, where the mass times the specific heat of it times the change in temperature. Then, since there's no change in temperature, obviously this formula is not going to work. But what will work is this here, when you're going to multiply the mass of the substance, oftentimes in kilograms, but in our case, we're going to use grams, and the heat of fusion of the substance. Here again, it's joules per kilogram, but that's only because this mass is in kilograms. In our case, we're going to have grams on both cases, right? But then the Q is the heat energy that is absorbed or released. In this case, it is absorbed because it is positive and it is endothermic. Now, in your other notes that you were given on the thermal heat energy stuff, you have for freezing and melting the heat of fusion and the heat of vaporization. All right, notice again, joules per gram. So for every gram of water, it's going to take 340 joules of heat energy to melt that from 0 degrees ice to 0 degrees water. All right, good enough. Let's go on to the problem. If we look at number 3 here. In this case, then you have 35 grams of water at 0 degrees Celsius, right? And then if you're going to melt this, you're going to multiply by the amount, the heat of fusion, which was 340, the right number, right? 340 joules per gram. As the grams will cancel out, you'll be left with joules, which makes us happy. That's what we're looking for. And if we look at our handy calculator, then that gives us 11,900 joules of heat energy. I'm going to put the positive here to make sure we show that this is an endothermic process. All right. Now, if it changes to the situation down here where you have 50 grams of condensing water vapor. Now notice it's released to the environment when water goes from gas to liquid or liquid to solid. When it becomes more orderly, it has to give off energy in the process, and it is exothermic. That's why if you're ever in a situation where there's lots of condensation, like a greenhouse, you're going to get it's going to feel warmer because all that extra heat is being given off by the environment, by the water to the environment. So in this case, then the Q will be 50 grams of water times the vaporization constant, which is 2,300 joules per gram. But because it's going in the opposite direction, the energy is released all right, and then that will be your multiplication again. Grams cancel, etc. You can figure it out that way. All right. So make sure that you see the difference here. If the temperature is not changing, then that the energy that or the equation that you're going to use is not going to be the other one that you did, which was the Q is equal to mass times specific heat times the change in the temperature. Right? You're going to use the other one. Now, in this case, you're going to use this formula because you have a change of temperature. So that works that way. But contrast it with this one, where you have the amount of heat needed to convert this. All you're going to do is get a Q liquid to Q gas, and then you're going to use the heat of vaporization here. Right? The 2,300 joules per gram. All right. So hopefully that makes things clearer. Let me know if you have any other questions, and hopefully we'll be back together again soon. See y'all.